In this video, we will be looking at the concept of arithmetic progression. Okay. Now, in our previous class, we discussed the concept of sequence and series. But in this video, we will be talking about arithmetic progression. Now, the first thing you want to notice that, let's start with the definition. When we say arithmetic progression, what do we mean? Now, by definition, an arithmetic progression is simply a type of sequence in which consecutive terms differ by a constant term. That's it, or a constant number. All right. So, your simple definition is that an arithmetic progression is a type of sequence in which consecutive terms differ by a constant number. That is it, okay? And that constant number is called the common difference. We'll talk about that much more later. Now, what is important to note is that an arithmetic progression is usually called AP in mathematics, okay? So you can see this as AP. So when you see AP in mathematics, it talks about an arithmetic progression. Now, we said for arithmetic progression, we said the terms, right? The consecutive terms of an AP differ by a constant term, and we said the constant term is called the common difference. Now, one thing to note about a common difference is that it could either be positive or it could be negative. Now, take for instance, let's have this set of numbers. We have 1, right? We have 3, we have 5, we have 7, we have 9, we have 11. All right, and let's say this continues. All right, this is an infinite series. Right, we defined this in our previous session. But then let's look at this carefully. Or before we look at this, let's consider a second set of numbers. Let's say we have something like -2, and then we have -5, and then we have -8, and then we have -11, and then we have something like -14. All right, let me see this. Okay. All right, so let's say we have this. Now look at these two sequences, right? Look at these two sequences. Let me call this the first sequence. Let me call this the second sequence. Now observe the first sequence of numbers. What do you observe? You observe that these are the consecutive terms of the first sequence. 1, 3, 5, 7, 9, 11. Now you want to observe that each of the terms, each of the consecutive terms differ from the previous by +2. Because 3, if you have 1, if you add +2, 1 + 2 gives you 3, 3 + 2 gives you 5, 5 + 2 gives you 7, 7 + 2 gives you 9, 9 + 2 gives you 11. So you can see that each of the consecutive terms differ by a +2. This constant term +2 is called the common difference. And this is why what you have here is an AP. Is an arithmetic progression, because each of the consecutive terms here differ from the first one by a constant term, which in this case is +2. Looking at this, what do you observe? If I'm moving from -2 to -3, the difference between -2 and -3 is -3. Between -2 and -5. For the second term, if I move from -2 to -5, what I'll have there is -3. All right. If you have -2 -3, you have -5. -5 -3, you have -8. -8 -3, you have -11. -11 -3, you have -14. Meanwhile, to get this number, all you have to do, just take 3 minus 1, you have 2. That's all. For this one, repeat the same process. This would be -5. This minus this. So minus what you have here, -2, and that gives you -5. Minus minus is +2. -5 + 2 is -3. So you can see how we got -3. And recall that I told you that for an AP, that the constant term could either be positive, as in this case you have positive numbers, or it could be negative, as in this case you have what there, negative constant term. So positive constant term, negative constant term. So for an AP, we're looking at a sequence of numbers where consecutive terms differ by a constant term. And we said that constant term could either be a positive constant term, as you can see here, or a negative constant term, as you can see here. Put this out. Or a negative constant term, as you can see here. So this is the concept of AP, all right? All right, having said this, let's look at something worthy of note for an AP. Note that for an AP, arithmetic progression, the first term of an AP is usually A, and the common difference is usually D. All right. So when you have a sequence of numbers in arithmetic progression, the first term is usually A, and the common difference is D. Now, when we say common difference, your common difference is simply that constant term by which consecutive terms differ. That's it. That constant number by which consecutive terms differ is called the common difference. That means for this sequence here, your A, for the first one there, A, your first term is what there? 1. So you can see here. While D, your common difference for this one is what there? Plus 2. That's a common term, right? Or that's a constant term. For the second one here, A, your first term is what you have here, your very first term, minus 2. And for the second one there, the constant term that consecutive term differs is minus 3. So that's it. All right, so that's the concept of first term and common difference, okay? All right, moving on. Let's look at something called the nth term of, let's look at the nth term of an AP, all right? Let's look at something called the nth term of an arithmetic progression. All right. So nth term of an AP. All right. So we have this nth term of an AP. Now, the nth term of an AP is a formula that helps us to get the formula for each of the terms of an AP. Note that, let's say the nth term of an AP is Tn. The formula is given by A plus n minus 1 d. So you have this. All right. A plus n minus 1 d. So this is the nth term of an AP, where A, as we said, is first term. Okay. So A is first term. It's already here. So I won't have to write it again. A is first term. D. Okay, let me just write this again, just for reference. For first term, A is already first term. We said D is common difference. D is common difference, then N is the number of terms. Number of 10, or the term in question. Right? So N could be either the first term, the second term, or what have you. Let's take N to be 1. For first term, let's say first term of an AP. For first term, we said N is what? The number of terms. For first term, N will be equal to 1. Since we're looking at first term, that means T1 will be equal to A, first term, plus N minus 1. What is N here? N is 1. Say first term. So it becomes 1, N minus 1. So minus 1. And then what again there? D. So we have this. This will be equal to A plus 1 minus 1 gives you 0 times D. So you have D here. This is equal to A. 0 times D gives you 0. So it's off. So the first term is equal to what there? A. And that's why we say the first term of an AP is A. So that's your proof. Let's look at second term. Let's use the same concept. In this case, let's look at second term. For the first term, N is 1. For second term, N will be equal to what there? 2. So put N as 2 into this. This becomes Tn. That becomes T2. T2 is equal to A. So A plus N. N we said is 2 in this case. So 2 minus 1 minus 1. And then D. So you have D here. Now work on this. This is equal to, you have A plus 2 minus 1 is 1. So A plus 1 times D. You have this. And this is equal to A plus 1 times D is D. So you have A plus D. And this is second term. Let's look at third term. All right. For the third term, of course, n will be equal to what there? 3. So we have this. Now, when n is 3, what do you have here? T3 will be equal to A plus n in bracket. N is 3, so 3 minus 1, and then D. So you have D. Work on this. This is equal to, you have A plus 3 minus 1 is 2, then times D. So you have A plus 2D. Let's take one last one there. Let's look at the fourth term. For fourth term, we know that n will be equal to what there? 4. All right, let's try to get the T4 term. For this, we have that T4 is equal to A. So A plus n. In this case, n is 4, right? N is 4. So it becomes 4 minus 1 minus 1. And then you have D. So you have D here. This is equal to A plus 4 minus 1, 3. And then you add D. So in essence, for an AP, the first term, I'm going to line this. The first term is A. The second term is A plus D. The third term is A plus 2D. The fourth term is A plus 3D. So this is the nth term of an AP. So from this, you can get the 100th term. All right. The simple concept is that if you're looking for third term, subtract 1 from this number, there are 3, you have 2, then attach it to D, that's all. In essence, we are saying that the 100th term, T100, will be equal to A plus, all right? It always starts with A plus, A plus, A plus. Then what follows next becomes, this is fourth term. So for T4, it becomes 4 minus 1, which is 3, they attach D. For 100, it becomes 100 minus 1. That gives you 99D. So the 100th term is A plus 99D. If you're looking for the 70th term, that's T70. For T70, don't forget it starts with A plus. So I'll have A plus 70 minus 1 is 69, then attach D. All right, so A plus, subtract 1 from that number, then attach D. That's a simple concept, okay? A plus, subtract 1 from that number, attach D. So with this, we can now get the nth term of an AP. All right? All right, guys, so let's pick out a question, a very simple question on AP, and try to solve that question. All right, so let's take a first example on arithmetic progression. The question here says, find the 15th, 20th, and then nth term of the sequence minus 3, 2, 7. D part says, which term of the sequence is 217? All right, let's look at the question there. First things first, what we're given here, the sequence is minus 3. We have minus 3, we have 2, and then we have 7, and then it's continuous. All right, so we have this. So we have this here. We said we should find the 15th, the 20th, and the nth term. Let's start with that one first. So we have to find 15th, 20th, and nth term. Before we do that, let's get the value of A, the first term, and then D, the common difference. So how do we get A? A is your first term. Merely looking at this sequence here, your first term is the first number you have here, which is minus 3. So A is minus 3. You have this. Now, to get your common difference, next up, we can see that the second term is 2. To get your common difference, you could just say second term minus first term. And that will be second term 2 minus your first term minus 3. So minus 3. Second term minus first term. This would give you 2. Minus gives you plus. Then you have 3. 2 plus 3 gives you what there? 5. So you have this as 5. So this is how we could get the common difference. Or you could say, this is my first term. This is my second term. And we've said the second term is simply a plus this. We said this earlier, right? So a plus the second term is equal to what you have here. What do you have here? 2. I could call this equation 1 and call this equation 2. If I put equation 1 into 2, right? That simply means replace the value of a here by what you have here. That means if I replace a by what I have here, we have a plus d. But we said that a is minus 3. So replace a here. So this a here becomes minus 3 plus d. So plus d is equal to what I have here, which is what there? 2. To get d, move this one over here. We have that d is equal to 2 minus 3 crosses equality sign. It becomes plus 3. 2 plus 3 gives you what there? 5. The same answer as we had here. All right. So the question says we should find the 15th term, the 20th term, and the nth term. So before we do that, let me just confirm that that was the question. Let's see. 15th, 20th, and nth term. All right. Let's get 15th term. The 15th term, 15th term, this is the A part. All right, this is the A part, 15th term, that's T15. We know that using the nth term of a sequence, 15th term becomes A plus 14D, all right, or N minus 1D, A plus N minus 1, which is simply 15 minus 1 and then D. We said this earlier. Now, imputing values, this is equal to the value of A, as we had, is minus 3. Minus 3 plus 14 minus 1 is 15 minus 1 is 14. And then you have D. The value of D, as you have it here, is 5. All right? So 15th term is equal to minus 3 plus, this should give you about 70. 14 times 5. That's about 70. Yes, that's 70. So we now have minus 3 plus 70, which is 67. All right. So the 15th term, T15, is 67. That's the value. Next up, you ask to find 20th term. So 20th term. Now, for 20th term, that's simply T20. T20 is equal to A plus N minus 1. N here is 20. That becomes 20 minus 1. Then you have D. All right, impute values. So A, as we had it, is minus 3 plus 20 minus 1 is 19. And then you have D. What is D there? D is here. D is 5. Please, what you have here is D, not A. This is D. D is 5. So you have this as 5. This is equal to minus 3 plus, if you multiply this, you have 95. All right, just to, okay, you have 95. Yep. So minus 3 plus 95, that will give you 92. All right, so this is value of T20, 92. Finally, we are asked to find C part, so we should find the nth term. So nth term. All right, so the nth term, Tn, we said is given by A plus N minus 1, then you have D. All right, so this is equal to, what is A? A is minus 3 plus N minus 1, the nth term. So we don't know what N is, so we're having N minus 1 into D. The value of D is 5. We have this as 5. Let's multiply it. This is equal to minus 3 plus 5 times N. We are trying to expand the bracket now, right? 5 times N is 5N minus 1 times 5, or 5 times minus 1 is minus 5. So we have this. Now working on this is equal to minus 3 minus 5. Minus 3 minus 5 gives you minus 8. So it becomes minus 8 plus 5n. This is the nth term. All right, but usually in mathematics, we take the positive term before the negative term. So I'm saying that we now have that Tn, taking positive first, becomes the plus 5n, then then minus 8. So this is the nth term, right? Yep, this is what you have. So that's your nth term, right? So positive first, 5n, and then negative, minus 8. By the way, if you leave it this way, there is nothing wrong with it, okay? Still okay, but then it's better you present your answer in this way. Take positive first before negative. All right, so that's the thing here. I think we're given a D part. Let's see. Yes. D part said, which term of the sequence is 217? So let's solve that one there. Which term of the sequence is 217? Okay. Which term of the sequence is, this is D part, last part, the D. Which term of the sequence is 217? So at 217, the value of n, what term of it is unknown? All right, so how do we solve this question? Well, all we have to do is that let's get the nth term. We said the nth term of a sequence, Tn, is equal to 217. That's how we present this mathematically. A particular term which is unknown, we'll call it Tn. So the nth term of a sequence is 217. Now your question is to find which of the term, at what nth term will we have 217. That's the task. And all we have to do here, thankfully, we already have a value for Tn, right? Nth term, Tm, is 5n minus 8. From here, you have Tn, 5n minus 8 is equal to what there? 217. You have this. All right. So next up, we'll move minus 8 over here. We have 5n is equal to 217. Minus 8 crosses over here, becomes plus 8. So we have this. From here, we have 5n is equal to, if you sum this up, 217 plus 8, that gives you about 225. So you have here as 225. All right. Next up, divide both sides by 5. Divide here by 5. Divide here by 5. This cancels this. So n is equal to 225 divided by 5. That should give you about 45, right? Let's see. 45. Yes, 45. So it is the 45th term that will give you 217. So I'll write there. Below is I'll write, hence, the 45th term would give 217. So basically, this is how you solve this question. All right. So if you enjoyed this video as usual, make sure you hit the like button. Or before then, your task, I'm giving you this stuff here. Your task here is to find the 200th term. All right. What is T200 for this? For the same question, right? What will be the 200th term? Solve this question. Leave your answer in the comment section, and I'll tell you if you're correct. By the way, I've already given you a hint. This is the value for Tn. Now replace n with 200 here. What will you get? Leave your answer in the comment section. Let's look at this question on arithmetic progression. All right. The question here says the fifth term of an AP is minus 12 and the 10th term is minus 27. Find the AP and the 15th term. All right, so that's the question there. So how do we solve this question? Now, solution. Let's look at the question step by step. The first thing here we are told is that the fifth term of the AP So solution, what are we given there? So given, the first thing we're given there is the fifth term of an AP. And we've said the fifth term of an AP is given by A plus 4D, right? N minus 1. 5 minus 1 gives us 4. A plus 4D. The fifth term of an AP gives us how many there? We said it's minus 12. So this is minus 12. This is your first thing you're given there. They said, and the 10th term. Number 2, you're given the 10th term. 10th term is A plus 9D. That's 10th term. Right? 10 minus 1 gives you 9. A plus 9D is how many there? Minus 37. So this is your 10th term. You now said we should find the AP and the 15th term. Let's find AP. Let's find 15th term. Before we do that, we'll call this your first equation, equation 1. We'll call the second equation, equation 2. All right? Our first task would be subtract equation 2 from equation 1. And how do we do that? Equation 2 is given by A plus 9D as equal to minus 27. Equation 1 is given by A plus 4D as being equal to minus 12. We have this. Let's subtract them. So minus here. Now what you have here is A minus A. A minus A gives you 0. So it cancels out or it is gone. Next up you have 9 minus plus 4. Minus plus is minus. So it becomes 9 minus 4, which is 5, and then bring down the D. So 9D minus 4D gives you 5D. This is equal to, next up, what you have here becomes minus 27 minus 12. Minus gives you plus. Minus 27 plus 12. Minus 27 plus 12 gives you minus 15. So you have this as minus 15. All right? Yep. Minus 15. To get D, I'll divide here by 5. I'll divide here by 5. This will cancel this. So D, which is your common difference, is equal to minus 15 divided by 5 gives you minus 3. So the value of the common difference, D, is equal to minus 3. Having got the value of D, we will substitute into equation either 1 or 2 to get the value of what? A. So let's get that done. All right, so I'll put D equal to minus 3 into, I've said you could choose to substitute into either equation 1 or equation 2. But looking at this, I can see that equation 1 has smaller numbers. So I'll choose to go with equation 1. So into equation 1. All right. From equation 1, we have that A plus 4D, A plus 4D is equal to minus 12. So equal to minus 12. To get A, I'll move 4D over here. We'll have A is equal to minus 12 plus 4D comes over here becomes minus 4D. Now put the value of D as minus 3. So say put D as minus 3. Put D as equal to minus 3. So what do we have there? We have that A. So A is equal to this minus 12. So minus 12 minus, is it minus? Yep, minus 4 times D. So minus 4 times D. All right, so we have this. From here, A is equal to minus 12 minus 4 into D. What is D there? D is minus 3. So into minus 3. So we have this. Working on this, we have that A is equal to minus 12 minus times minus plus 4 times 3, 12. So we have minus 12 plus 12. A will be equal to what there? 0. So your first term, A, is equal to 0, while your common difference, D, is equal to what there? Minus 3. Now we've gotten the value of A and D. Let's proceed to solve the question. What did the question say here? Give me a second. Let me open it. The question here says what there? Find the 15th term. That's the question. Find 15th term. So 15th term, your 15th term is simply T15, all right, T15, all right, and we know that T15 is equal to A plus 14D. We've said this before. 15 subtracts 1. 15 minus 1 gives you 14. So A plus 14D. Let's put in values. This is equal to A, 0, plus 14. Yep, 14 into D. The value of D is minus 3. So minus 3. So T15 is equal to 0 plus minus 14 times 3. That should be 42. Yeah? Yep, minus 42. 0 minus 42 is equal to minus 42. So the 15th term, T15, is minus 42. That's your answer. Is that all the question? Let's see. Yep, that was all. Find the 15th term. All right, so we have this. Now, in this question, assuming they said you should find the nth term, I want to give you a task. Assuming you're asked to find the nth term, what would you have done? All right, so I want to give you a task now. In this question, give the expression for the nth term. Tn is equal to what? That's your task. What do you think the nth term for this particular question would be? I want you to solve this question, leave your answer in the comment section, and I will tell you if you're correct or not, right? Give an expression for Tn in the comment section. I'll give you a reply, and I'll tell you if you're correct or not, all right? Let's look at this question on AP, all right? The question here says, the sum of 3 consecutive terms of an AP is 21, and their product is 315. Find the terms. All right, that's the question there. Find the terms. All right, so how do we solve this question? Solution, please. All right, solution. So we have this. We are told that the sum of 3 consecutive terms, all right? So the 3 consecutive terms could be your first term, your second term, and your third term. And they said their sum is 21 and their product is 315. So let me just write this down. The sum of the 3 terms is 21 and the product of the 3 terms is 315. So we have this. We are asked to find the AP, all right? So find that AP, find that sequence where the sum of the first 3 terms of the sequence would give you 21, and the product of the first 3 terms would give you 315. So how do we solve this question? What do we do? Now, we know that for an AP, usually the first term of an AP is A, the second term of an AP is A plus D. The third term of an AP is A plus 2D, as we have already established in our previous class. Now, if you have this, and we ask to find the sum of the first 3 terms. Now, this would be this plus this plus this. Now, if you do that, you have A plus A plus A, which is equal to 3A. So that's 3A. Then you're having D plus 2D, which will give you 3D. So basically, you're having 3A plus 3D equal to their sum, which is 21. Now, when you have 2 unknowns, there is no way you can solve them except you have a simultaneous equation. In essence, we should not use this. All right? We could do something else. What is that? Let's subtract D from each of these. Subtract D from here. This minus D becomes A minus D. So I have this as A minus D. Okay. Subtract D here. So minus D. You have A plus D minus D. Plus D minus D cancels out. It's basically you saying D minus D. That's 0. It goes off. You're left here with what? A. Subtract D here. So minus D. This becomes A plus 2D minus D. that is a single D. So you have A plus D. So instead of using A plus D, and A plus 2D, rather you could use A minus D, A and then D. So we'll say let the three consecutive terms, let the three consecutive terms be A minus D, A and A plus D, as we've established there. Let's take their sum. Their sum would give you this one first, A minus D plus A plus A plus D. Their sum is equal to 21. So you have here as 21. All right, remove the brackets here. Let's solve this. Removing brackets here, I have A minus D, this one here, plus A plus this one here, A plus D. This would be equal to what there? 21, as we have here. From here, A plus A is 2A, 2A plus A is 3A. So we have 3A minus D plus D. That gives us 0, or it cancels out. So this will now be equal to what there? 21. All right. So if we use the consecutive terms as my A minus D, A, and A plus D, you can see that one of the unknowns, which is D, will cancel out. And that's why I said we should use this one instead. This one instead of the first one. This first one will leave us with two unknowns, which will be difficult to solve because we don't have a second equation to solve them simultaneously. We don't have. And this one becomes problematic to work with. So instead, we work with this one. So you can see we now have 3A is equal to 21. To get the value of A, divide here by 3, divide here by 3. This will cancel this. So A is equal to 21 divided by 3 gives you 7. So with this, we've gotten the value of the first term. The first term, A, is equal to 7. All right? What was the next thing there? They said that their product, okay, is 315. All right, let's take products. Their product, all right, let's take their product. Their product becomes this times this times this, which is A minus D multiplying A plus D. This is equal to 315. So I have 315. So you have this. All right, let's multiply this. We could choose to multiply straight, or we could just choose to put the value of D. Since we already have the value of D. Okay. Yeah. All right. Should we put the value of D first, or do we multiply first? Okay. Let's say this. So first things first, bring A outside here. So I have A into, bring this A outside. Then you have this one here, A minus D. Then you have this one here, A plus D is equal to 315. Now I have repeated the same thing. I just brought the A outside here. That's all. All right. All right. Next up, let's see what do we do next. At this point, you could choose to keep solving this, or you could just replace the value of A as what? 7. All right. So let's say put A as 7. Put A as equal to 7. All right. I'll just get my calculator so we can solve this. All right, let me get my calculator. All right, so A becomes 7 into A minus D becomes 7 minus D. A is 7 into A plus D. A is 7, so 7 plus D is equal to 315. The first thing I could do here is to divide here and divide here by 7, since they are all multiplying by 7. So this will cancel this. So you have 7 minus D into 7 plus d is equal to 315 over 7. That's 315 over 7. That's about 45. So it's equal to 45. You have this. Now let's keep on solving this. For this, we have to expand the brackets. To expand the bracket, we'll have 7 times 7, 49, plus 7 times d, 7d, minus 7. Use minus 7 now to multiply. Minus 7 times d, minus 7d, minus plus, minus d times d, d squared is equal to 45. Now proceeding with this, obviously I'll have to move this over here. And of course, 7d minus 7d, this will cancel this. So I'm left with 49 minus d squared is equal to 45. Move 49 over here. I'm having this as minus d squared is equal to 45. 49 comes over here, becomes minus 49. We have this. All right, next up we have minus d squared is equal to 45 minus 49 gives you minus 4. Of course, minus cancels minus. You have that d squared is equal to 4. Let's get the value of d. Now from here, to get the value of d, we'll take the square root of 4. All right, square root of what I have here, 4. And we know that the square root of 4 is equal to what there? Plus or minus 2. All right, the square root of any term is equal to plus or minus its value. So it's not just plus 2. It could also be minus 2. So the value of d is equal to plus or minus 2. Let's see at d equal to plus 2. Right? Let's take plus 2. If it is plus 2, we said the sequence is a minus d, a plus d. All right. What's the value of a again? We got a at 7. That becomes 7 minus d is plus 2. So 7 minus 2, and then a is 7, and then a plus d, that becomes a is 7, 7 plus d is 2, so plus 2. And that means we'd have the sequence, the first 3 terms of the sequence as being what's there. 7 minus 2 is 5. Then we have 7 plus 2 is 9. So if a is plus 2, the sequence, the first 3 terms of the sequence is 5, 7, 9. That's your answer. What if, so let's say at d equal to, what if it is minus 2? If it's minus 2, what do you have? We'll have that the sequence is the sequence is still the same thing there, a minus d, a plus d. All right, so it becomes a minus d. That becomes a minus, sorry, the value of a is 7. Becomes a 7 minus d. D is minus 2. So a minus d. D is now minus 2, comma, and then a is 7, and then a plus d. So it becomes 7 plus d. D is now minus 2. Work on this. This gives you what there? This gives you 7 minus minus plus 2, and then 7, and then this one here, 7 plus minus minus 2. So what do we have there? 7 plus 2 is 9, and then 7, and then 7 minus 2, we have 5. In essence, this question has 2 possible kind of sequence. The first sequence is 5, 7, 9 in increasing order. or the second sequence could be 975 in decreasing order, right? So we asked to find the sequence, right? Hold on, let me check the question again. The question exactly here was we should do what? Let me see. Find the terms. All right. So the terms we asked to find would be 5, 7, and 9, or 9, 7, and 5. It's the same thing, just arranged in different orders. One in increasing order, and the other one there in decreasing order. All right. All right. So let me give you a task. Let me give you a question for you to solve. Let's see. So let me give you a task real quick. So here's your question. The question here says the sum of three consecutive terms of an AP is 6 and their product is 90. Please. The question here is the sum of three consecutive terms of an AP is 6 and their product is 90. Find the terms. All right? Find the terms. That's your question. Leave your answer in the comment section and I'll give you a reply. I'll tell you if you're correct or not. All right? Let's look at this question on arithmetic progression. That's AP. The question here says the ninth term of an AP, that's arithmetic progression, is 3 times the fifth term. A says find a relation between the first term, and that's the first term A, and the common difference D. B says prove that the eighth term is 5 times the fourth term. All right, so that's your question. For this question, let's take down the solution. So solution, let's solve this question. Solution. All right. So what are we given here? In this question, we are told that the ninth term of an AP. Now we know that ninth term given. We know that ninth term. So ninth term, that is A plus 8D. That's a ninth term. A plus 8D. They said is 3 times the fifth term. What's a fifth term? What's the nth term for a fifth term? We know that fifth term is A plus 4D. The question says the ninth term, that's T9, is 3 times the fifth term. 3 times fifth term, that's T5. All right, so that's it. We have to find what there? A relation between the first term and common difference. All right, let's get the relationship between the first term and common difference. And how do we do that? Let's replace value. What is T9? T9, ninth term, is A plus. This is T9 actually. All right, this is T9. This is T5, fifth term, T5. T5. So the ninth term, A plus 8D, is equal to 3 times, so 3 into the fifth term, A plus 4D. We have this. All right, so if you have this, let's expand bracket. This becomes A plus 8D is equal to 3 times A gives you 3A plus 3 times 4D gives you 12D. So I have this. Okay, let's collect like terms. All we have to do is move everything over here. So if you move everything here, this becomes 0. So 0 is equal to, this becomes 3A plus 12D plus A comes over here becomes minus A plus 8D moves over here becomes minus 8D. So I have this. Let's collect like terms. 0 is equal to 3A minus A. 3A minus A gives you 2A. Then you now have 12D minus 8D. 12D minus 8 gives you plus 4D. So I have this. All right, looking at this, we can see that you have 2 and 4, which is very much factorizable. This becomes, let's interchange this. 2A plus 4D is equal to 0. It's the same thing, all right? Just swap positions. So So you have this. All right, so what next? We can factorize. There's 2 here, there's 2. Let's factorize 2. Bring out 2 here. 2a divided by 2 gives you a, plus 4d divided by 2 gives you 2d. So this becomes 2d is equal to 0. You can expand this. 2 times a gives you 2a. 2 times 2d gives you 4d is equal to 0. Now, at this point, we can choose to divide both sides by 2, divide here by 2, and divide here by 2. This will cancel this. So I have a plus 2d is equal to 0 divided by 2 gives you 0. From here, to get the relationship between a and d, this d can come over here. So we'll have that a is equal to, this is plus 2d, plus 2d comes over here, becomes what there? Minus 2d. So the first task, we are asked to find the relationship between the first term and the common difference. So that relationship is given by a equal to 2d. That means the first term is equal to negative 2 times the common difference. This is the required relationship. All right, what next? Let's look at the second part of that question. The second part of the question here, we've done the first part, that's A, which is this. Second part, B, says prove that the eighth term is 5 times the fourth term. Prove that eighth term is 5 times the fourth term. B, say we should prove that eighth term, T8, is equal to 5 times the fourth term, T4. That's a tax for B. And how do we prove that? Let's simply get the value for T8. For T8, the eighth term, T8, we know that for an AP, the eighth term is usually A plus 7D. This is A plus 7D. This is the expression for the eighth term of an AP, A plus 7D. Yeah. What's the value of A? We already had A here as what there? Minus 2D. So put A as minus 2D. Put A as equal to minus 2D. From this part here, you have that T8 is equal to A, which is minus 2D plus this one here, 7D. And that's equal to minus 2D plus 7D. Minus 2 plus 7 is 5. That is 5D. So in essence, we're saying that T8 is equal to 5D. So T8 is equal to 5D. Let's get fourth term. All right, fourth term. Also, the fourth term, T4, the expression for fourth term is A plus 3D. All right, so A plus 3D. This is the expression for fourth term. Let's put A, please. Let's put A. We said A is what there? Minus 2D. Put A as minus 2D. What do you have there? We'll have that T4 is equal to A, which is minus 2D. That's A minus 2D, then plus 3D. Plus 3D. If you do this, what do you have there? We'll have that T4 is equal to minus 2 plus 3 gives you what there? 1. 1 times D gives you what there? D. All right, so what do you observe here? Observe that T8 is 5D and T4 is D. And we know that 5D is equal to what there? 5 times D. In essence, the T8, the eighth term, 5D is equal to what there? 5 times the fourth term, D. So from here we can now say, since 5D is equal to 5 times D, hence the eighth term, T8, is equal to 5 times the fourth term, D. So this is how you prove this question. All right. So basically, this becomes the solution to this question. All right. So as usual, I will leave you with a task for you to solve. Let me get the question for you. Let's see. So let me get a question for you real quick. Your task is this. Which term of the AP 2, 5, 8 is 44? So that's your question there, right? Solve that question. Now, if you enjoyed this video as usual, do well to hit the like button. All right, like this video and do well to leave a comment. I give you a task for you to solve. Pause this video, solve that question, leave your answer in the comment section, and I'll give you a reply. I'll tell you if you're correct or not. Let's look at the concept of arithmetic mean. All right, let's consider arithmetic mean in this video. Now, first things first, when we talk about arithmetic mean, let's say we're given a particular sequence. Okay, let's say we're given a sequence A, B, C, all right, a sequence of terms A, B, C. Now, for this sequence, B is said to be the arithmetic mean of A and C. So your middle term B is said to be the arithmetic mean of A and C. Why? Well, the result is simple. The answer is simple. And the answer is that the value of B will be equal to the value of A plus the value of C, all divided by 2. That's it. All right. I give you an example. Let's take for an example. Let's take something that looks like. Let's take something like 7. Let's take 18, and let's take 29. All right. Let's take this 7, 18, 9, and 29. These are or this is a sequence in arithmetic progression. Now, we said the middle term B will be equal to the sum of these terms. So if I take the sum of 7 plus 29, take this sum divided by 2, that will give you 7 plus 29 is 36. 36 divided by 2 is equal to 18, which is what you have here. So this is what we mean when we say 18 is the arithmetic mean of 7 and 29. That is the concept. So when you have a sequence in arithmetic progression, all right, that middle term between two terms is usually called an arithmetic mean. All right. But if you look at the concept of arithmetic progression in AP, if we have terms such as A, B, C, D, E, F, G. Let's say we have this sequence A, B, C, D, E, F, G, and they are in arithmetic progression. When we say arithmetic mean, we are taking those terms, all of the terms, between the first and the last. So the arithmetic mean of A and G would include B, C, D, E, F. That's 1, 2, 3, 4, 5. So we have 5 terms as the arithmetic mean between A and G. All right. So this is the concept of arithmetic mean. All right. All the terms in between your first term and a particular term, usually your last term, in consideration. That's it. The question here says, insert 4 arithmetic means between minus 12 and plus 13. That's your task. Insert 4 arithmetic mean between minus 12 and plus 13. All right, solution. 4 arithmetic means 4 arithmetic means between let's see, between minus 12 and 13. Between minus 12 and 13. So you have this 4 arithmetic mean between minus 12 and 13. Now, how do you solve that? What do you do? The first thing you have to do is the first term here would be minus 12, right? You're adding 4 numbers. Let's call the 4 terms. Let's call the 4 terms X, Y, Z, and A. So these are the 4 terms I'm inserting. X, Y, Z, A. They said 4, so I'm putting 4. Between 12 and I'll now have 13. All right, we said for arithmetic terms, these are the arithmetic means between minus 12 and 13. Four of them, X, Y, Z, A. You could use any alphabet of your choice. So it's left for you. All right, so with this, we are now saying that these terms are in arithmetic progression. If these terms are in arithmetic progression, what can we say? We can say this is the first term, yeah, second term, third term, fourth term, fifth term, and sixth term. Hence, we have that first term. In AP, we said first term is A, and A is equal to what there? Minus 12. All right. So A is minus 12. Then we now have this is A. This is second term, third term, fourth term, fifth term, and sixth term. So sixth term is A plus 5D. This is the nth term for a sixth term, A plus 5D. And the value as we have is plus 13. All right, so A plus 5D equal to plus 13. With this, let's get the value of D. Already, we can see that the value of A is a no-brainer. Simple. It's just minus 12. So let's get the value of D. So A becomes minus 12 minus 12. A plus 5 into D. 5D, we don't know what the value of D is. So 5D is equal to 13. We have this. So your task is very simple. All right, your task is simple. This is A. A is minus 12. Just put that value here. So A is minus 12 plus 5D equal to 13. From here, we'll have 5D. 5D is equal to 13. Minus 12 comes over here, becomes plus 12. So we have this. From here, we have 5D is equal to 13 plus 12 gives you 25. To get D, divide here by 5, divide here by 5. So this will cancel this. D is equal to 25 divided by 5 gives you 5. So D is 5. We have D as 5. So with this, we've gotten our first term as minus 12. We've gotten D as, or common difference, as 5. At this point, we can now insert the four arithmetic mean. All right, this should be an M. I knew something was off here. All right, this is arithmetic mean. All right. Right. Okay. So let's get the terms there. The terms will be X, Y, Z. Now, first, second term. The second term, which is X. For second term of an AP, second term is A plus Z. Yeah? And so X will be equal to A, which is A is minus 12 plus D. D is what there? 5. Minus 12 plus 5, that's equal to minus 7. So we've gotten X as minus 7. So first term, X is second term, Y is third term. So third term, that's Y. For an AP, the third term is A plus 2D. Let's impute the value. That means Y is equal to A. What's the value of A again? A is minus 12. A plus, you have 2D. 2 into, what's the value of D? D is 5. Okay, this is equal to minus 12 plus 2 times 5 is 10. Minus 12 plus 10 is minus 2. All right. We've gotten the value of Y as minus 2. Let's get the value of Z. Z will be equal to, what about Z? Z is the third term. First term, second term. So Y is the, X is the second term, Y is the third term. So Z will be the fourth term, right? Z is fourth. Fourth term, Z. All right. For fourth term, what's the expression? For your fourth term, the expression is A plus 3D. That's for an AP. Fourth term is A plus 3D. Let's impute values. So Z will be equal to A minus 12 plus 3 into D. D is 5. Work on this. This gives you minus 12 plus 3 times 5 is 15. Minus 12 plus 15 gives you plus 3. So you have 3 there, or plus 3. That's your answer. And then finally, fifth term. The fifth term there, right, it's A. So first, second, third, fourth, fifth. The fifth term is A. Fifth term, A. For your fifth term, the expression for the nth term will be A plus 4B. You have this. Okay, let's get this done. So A will be equal to A. There isn't A here, there's already A. Should we use A? We could change the A to something else. Since we already have A here, we could change to something else. Let's use Q instead. All right, please get what we're using Q. We're using Q because we already have A already, okay? That's proper that way. So let's just change this to Q. So the fifth term, Q, is equal to A plus 4D. So Q is equal to A. What's the value of A? The value of A is minus 12 plus 4 into D. The value of D is 5. Yeah. So we have 5. This will be equal to minus 12 plus 4 times 5 is 20. Minus 12 plus 20 gives you plus 8. So you have 8 there. Minus 12 plus 20 gives you plus 8. All right, so we have this. So therefore, the sequence is given by the first term, that's minus 12. Then we have x, value of x is minus 7. Okay, and then we have the third term, minus 2. And then we have the next term, then the fourth term, 3. So 3. And then we have the next term there, 8. And then we have the final term there, 13. So we have 13. So if you look at this, we've inserted 4 arithmetic mean, 1, 2, 3, and 4, between minus 12 and 13. All right, so basically, this is how we solve this question. So as usual, let me leave a task for you. So your task is this. Insert 6 arithmetic mean between 1 and 15. That's your task, all right? Insert 6 arithmetic means between 1 and 15. That is your task. So between 1 and 15, insert 6 arithmetic mean, all right? So solve that question, leave your answer in the comment section, and I will give you a reply. I will tell you if you're correct or not, all right? Let's take another question on arithmetic mean. The question here says, insert 7 arithmetic means between 2 and 26. All right? Insert 7 arithmetic means between 2 and 26. All right. So let's solve that question. Solution. 7 arithmetic means. So 7 arithmetic means between 2 and 26. All right, let's solve that question. So how do we solve that question? What do we do? Now, to solve this question, we'll have 2 and 26. So 2, we'll insert 7 terms in between them. Let's take them as, let's take the terms there as B, C, E, F, G, H, M. Let's see. 1, 2, 3, 4, 5, 6, 7. All right, these are 7 terms in between 2 and 26. So we can now stop here. All right, so we now have 2. Then we have 7 arithmetic means. That's B, C, E, F, G, H, M. That'll be 1, 2, 3, 4, 5, 6, 7. 7 between 2 and 26. So we have this. All right. Our task here will be to find the value of B, C, E, F, G, H, and M. So how do we solve that? First things first, we say let A. This is my first term. So first term A will be equal to what I have here, which is what? 2. So this is first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term, ninth term. So we have a value for the ninth term. So we can say ninth. All right, let's just take ninth term. Ninth term. Ninth term is given by A plus 8D. So A plus 8D is the nth term for a ninth term of an AP. Ninth term is equal to 26. Let's call this equation 1. Let's call this equation 2. If I put equation 1 into equation 2, put 1 in 2, so 2 you have A plus 8D is equal to what there? 26. What's the value of A? 2 from 1. So 2 plus 8D is equal to 26. So you have this. To get the value of D, move to over here. You have 8D is equal to 26 minus 2. You have 8D is equal to 26 minus 2 gives you 24. You have this. Right, divide here by 8. Divide here by 8. This cancels this. D is equal to 24 over 4. That will give you 3. All right, 24 divided by 8, please. Right, so 24 divided by 8, that gives you so from here we'll have D is equal to 24 divided by 8. That gives you 3. All right, so D is equal to 3. Okay, so with this we've got the value of D, the common difference. So we can now find the value of B, C, E, F, G, H, M. All right. So let's give them one after the other. Let's start with this is first, second. Second term is B. Second term, which is B. All right. B, second term. For second term of an AP, you have A plus D, and that's A. A is 2. 2 plus D. D is 3. So 2 plus 3 is equal to what there? 5. So therefore, we have that B is equal to 5. That's the value. Let's get third term. The third term there is C. C is A plus 2D. A plus 2D is the nth term for the third term of an AP. That becomes A plus 2 times D. D is 3. The value of A is 2, please. That's equal to 2 plus 2 times 3 is 6. 2 plus 6 is what there? 8. So we have that C is equal to 8. Let's call the next one there, fourth term. The fourth term, which is E from here, right? First, second, third, fourth. Fourth term is E. The fourth term of an AP is A plus 3D, and that's A, 2 plus 3D is 3. So we have this. This is equal to 2 plus 3 times 3. This and this gives you 9. 2 plus 9 is 11. So it means that E is equal to 11. That's the next term there. Let's get the next one. Fifth term. Fifth term, which is F. The fifth term of an AP is A plus 4D. That's the fifth term, A plus 4D. That's equal to A, 2 plus 4 into D. D is 3, as we got here. This is equal to 2 plus 4 times 3 is 12. That's 2 plus 12 is 14. So we'll have that F is equal to 14. That's value of F, 14. All right, let's get the sixth term. Sixth term. The sixth term here is G, and G is A plus, for sixth term, A plus 5D. That's A. A is 2. 2 plus 5 into D. D is 3. This is equal to 2 plus 5 times 3 is 15. That's equal to 2 plus 15 is 17. So that means that G is equal to 17. So I have this. Okay. Next up is seventh term. Seventh term. The seventh term there is H. H. For seventh term, you have A plus 6D, and that's A is 2. A is 2. So 2 plus 6. 6 times D. D is 3. So 2 plus 6 times 3. This is equal to 2 plus 6 times 3 is 18. 2 plus 18 is 20. So we have this. That means H is 20. That means H is equal to 20. So we have this. Okay. Then finally for M, eighth term. Eighth term, that's M, is equal to A plus 7D, and that's A plus 7 times D. D is 3. The value of A is already 2, so I'll put 2 here. 2 plus 7 times 3. That's 2 plus 7 times 3 is 21. That's equal to 2 plus 21 is 23. So it means that M is equal to 23. So we have this. All right, so therefore, the AP is given by what? Start with this one first. 2. After 2, you have what there? 5. After 5, third term, you have C as 8. And then we have fourth term, E as 11. And then we have fifth term, F as 14. And then we have sixth term, G as 17. And then we have seventh term, H as 20. And then we have eighth term, M as 23. And then we have final term, which is this one here, as 26. So if you count this between 2 and 26, I've inserted 1, 2, 3, 4, 5, 6, 7. I've inserted 7 arithmetic means between 2 and 26, and you have this. And just by observation, you can see that each of the terms differ by what? There, 3. 2 plus 3, 5, plus 3, 8, plus 3, 11, plus 3, 14, plus 3, 17, plus 3, 20, plus 3, 23, plus 3, 26. It's just that simple. All right, so here's your own task. Let me give you a task. Now, solve this question. The question here is this. Insert 4 arithmetic means between 7 and minus 3. All right? Insert 4 arithmetic means between 7 and minus 3. So pause this video, solve that question, leave your answer in the comment section, and I will give you a reply. I will tell you if you're correct or not. Let's look at the sum of the first n terms of an AP. All right. So this is a subtopic under AP, which is arithmetic progression. Now, in this video, we'll be looking at how to find the sum of a given number of terms of a particular arithmetic progression. All right. Now, when it comes to finding the sum of the first n terms of an AP, there's a formula we use. Now, first things first, the abbreviation for this is given by sum is S. So when you see S and then you see N, basically this means the sum of the first n terms of an AP. The abbreviation is SN. All right. Now, the formula to get the sum of the first n terms of an AP is given by Sn, and Sn is simply n over 2 into a plus t of n, where t of n is simply the nth term of an AP. Recall that we talked about the concept of Tn, that's the nth term of an AP earlier, when we said Tn is equal to a plus n minus 1d. We talked about this in our previous class on arithmetic progression. Now let's put this value into this. We'll have that Sn, the sum of n terms of an AP, Sn is n over 2 into, this becomes a plus Tn is given by a plus n minus 1. This into d. So you have this, right? Let's combine these terms. So Sn from here will be equal to n over 2 into, this gives you a plus a, 2a plus, I have this, n minus 1d. So you have this. All right, so this formula here becomes the formula to calculate the sum of n terms of an AP, right? N over 2 into n minus 1, then d, you have this. All right, so this is the formula we use to find the sum of the first n terms of a given AP. We'll take an example to solve this, all right, to explain this better. Now let's take a first example there. Example number 1, it says, find the sum of the first 40 terms of the AP 8, 7.5, 7, and it continues. Now solution there. We're given the AP 8, 7.5, 7, and it continues. This, we are asked to find the sum of the first, how many there? 40 terms. All right, of this AP. How do we get the sum of the first 40 terms of the AP? Now, what this formula helps us to do is that it helps us to quickly calculate the sum of a given number of terms of an AP without having to find all the terms of that AP. Now, for instance, looking at this question here, in this question, we are asked to find the sum of the first 40 terms of this AP. Now, in this AP here, how many terms do you have? We are given just 3 terms. The first term, 8. The second term, 7.5. The third term, 7. If we are supposed to get the first 40 terms, that means after 7, we'll get the next term and the next term until we get 40 terms. Imagine having to solve individually to 40 terms, and then when you're not having 40 different numbers, you have to combine them. That would be too tedious a task. But then, luckily for us, we have this formula. With this formula, we don't have to solve for all 40 terms. No. If we have the first term, if we get the common difference, we are good to go. We can find the first 40 term, the sum of first 40 term. We can find the sum of the first 100 term. We can even find the value of the sum of the first 1,000 terms without having to get the 1,000 terms individually. So that's the beauty of this formula. All right, let's put this to work. In this case, we have to find the sum of the first 40 terms of this particular AP. Now, as I said earlier, we don't have to start getting, this is first, second, third. We don't have to start getting fourth, fifth, sixth until 40. That's too tedious and that would waste time. So instead, let's get the value of common difference. Now, for this AP here, it's clear that the first term, A, is equal to 8. That's my first term. It's also clear that the second term, that's A plus D, second term, A plus D, is equal to what there? 7.5. From here, we can get the value of D. Let's call this equation 1, first term. Let's call this equation 2, second term. Let's put equation 1 into equation 2. If I put 1 in 2, what do I have there? From 2, I have this as A plus D. A is 8. So I have 8 plus D is equal to 7.5. All right, to get the value of D, move it over here. So D is equal to 7.5. This is plus 8. Moves over here, becomes minus 8. So I have this. So what's the value of D from here? D is equal to 7.5 minus 8 gives you minus 0.5. So minus 0.5 is the common difference. Now with that noted, let's now get Sn. So therefore, sum of first 40 terms, sum of first 40 terms of the AP all you have, you have Sn, so become S. In this case now, n is equal to, okay, we have Sn, fine. The formula, let's repeat the formula. We said is n over 2 into 2a plus n minus 1d. N minus 1d. We have this. So for first 40 terms, we'll have that n is equal to 40. All right, number of terms is 40. We got a as, where's a? This one here, 8. We got d as how many? We got d as, where are you? This one here, minus 0.5. All right, let's input values. So the sum S of the first 40 terms, 40, is equal to n over 2, which is 40 over 2 into 2a, that's 2 times a. A is 8 plus n minus 1. What's n there? 40. 40 minus 1. N minus 1 into d. D is minus 0.5. Let me just put this as a bracket so it looks better that way. All right. So we have this. Okay, let's simplify this. This is equal to 40 divided by 2 gives you 20. So 20 into 2 times 8 is 16 plus 40 minus 1 is 39 into this minus 0.5. So you have this. So proceeding with this is equal to, this gives you 20 into, what do we have here? This is 16. So just punch this real quick. Of course, plus minus gives you minus. Next up is 39 times 0.5. And that's about 19.5. 19.5. You have this. All right. So this is equal to 20 into 16 minus 19.5. That's minus 3.5. So we have this. Hence, the sum S of the first 40 terms is equal to 20 times 3 minus 3.5. That's minus 70. All right, so the sum of the first 40 terms will give you minus 70. All right, so basically, this is how we solve questions that involves sum of an AP. Now let's take one more question on this. Let's take one more question on this. Let's look at this question on the sum of an AP, right? The question here says, the first two terms of an AP are minus 2 and 3. How many terms are needed for the sum to be equal to 306? So that's your question. Solution. In the question that they said, the first two terms. So you're given the first term, A, as minus 2, and you're given the second term, that's A plus D. A plus D is your second term, right? It's given as what there? 3. So you have this as 3. All right. They're asking you how many terms are required such that when you sum them, your value is 306. That's the question. Now, to solve this question, first things first, we must get the value of D. Now, your first term is minus 2. We'll call this I. That's the first term. Your second term, II, is 3. So, let's get the value of D. Right? Let's get the value of D. From here, let's get D. To get D, we'll put equation 1 into equation 2. All right? For equation 2, we have A plus D. A plus D as equal to 3. A is minus 2. Minus 2, that's A, as you can see here. Plus D is equal to 3. Move this over here. So D will be equal to 3. Minus 2 comes over here, becomes plus 2. So D is equal to 3 plus 2. You have 5. So the value of D there is 5. So they're asking you the sum of how many terms gives you how many there? 306. Let me confirm that. That's 306, yes. Now, in this case, they're saying that Sn is equal to 306. So how many terms will you sum from this AP to get 306? They've given the sum as 306. You're expected to find the value of n. But let's recall something. How do we do that? But let's recall that n. Let's recall something. But Sn is equal to n over 2 into 2a plus n minus 1d. Recall this formula. Let's substitute values. Substituting. Let's impute values so we can get the value of n. You have that Sn, which is 306. 306 is equal to n is unknown. So we have this as n over 2 into 2a. That's 2 times a. What's the value of a? A is minus 2 here. This into minus 2 plus n unknown, n minus 1 into d. D is 5. So into 5, you have this. Okay? This would give you 306. 306 has been equal to, let's simplify what we have here. This becomes n over 2 into, simplifying this, you have 2 times minus 2. 2 times minus 2 gives you minus 4. Minus 4 plus 5 times n gives you 5n minus 5 times 1 gives you 5. So you have this. All right, let's proceed with this. From here, you have something that looks like 306 is equal to n over 2 into, this gives you, I'll take the positive first, which is 5n into minus 4 minus 5. Minus 4 minus 5 gives you minus 9. So we have this. Let's work with this. Now, to solve this, all right, all we have to do is to multiply through by 2, please. Multiply by 2. Multiply by 2. So So it becomes 2 into 306. This is equal to 2 times what I have here, n over 2 into 5n minus 9. The idea of multiplying by 2 is so that you can cancel out denominator, so it goes off. All right, 3 times 2 times 306 gives you 612. All right, 612 is equal to n, left with n, into 5n minus 9. So you have this. All right, so what next? Let's expand the bracket. Let's expand the bracket. If you expand bracket, you're having 612 as equal to n times 5n gives you 5n squared minus n times 9 gives you 9n. Move this man over here. You have 0 is equal to 5n squared minus 9n. 612 comes over here, becomes minus 612. You have this. All right, so at this point, we now have a quadratic equation. I won't spend all my time solving this. I will just go straight to using a calculator. Yeah, I could just go straight to using a calculator just to save time. So you should know how to, you could solve this using any of the methods, completing the square method or formula method. But I'll just go straight to using a calculator so that to save my time. If I punch this, so A is 5, B is minus 9, C is minus 612. So I'll use a calculator to punch this very fast. Let's see. So A is plus 5, B is minus 9, C is minus 612. If I punch that, you have that n is equal to minus 51 over 5. That's the first one. Or you have that n is equal to, you also have this as 12. As 12. So you have this. So your answer is either minus 51 over 5 or minus 12. They're asking you how many terms would you sum to get 306. There's no way your answer will be negative. How can you sum minus 15 terms? It doesn't make sense. Or minus 10 terms. I summed minus 10 terms. It doesn't make sense. In essence, in this case here, n cannot be negative. So instead, we take what? The positive values. Therefore, n is equal to 12. So the correct answer there is 12. They ask you how many terms would you sum for you to get 306. The correct answer is there is what? 12. You have to sum 12 terms to get 306. So this is how you solve questions on sum of an AP. As usual, I'll leave a task for you. All right, solve this question, leave your answer in the comment section. The question here says the sum of the first 10 terms of an AP is 15 and the sum of the next 10 terms is 215. Find the AP. All right, so find the AP. That's the task. All right, so see if you can solve that question. Leave your answer in the comment section and I'll give you a reply. I will tell you if you're correct or not. Let's look at this question on AP. The question here says the sum of the first 10 terms of an AP is 15 and the sum of the next 10 terms is 215. That's 215. Find the AP. So that's the question. All right, so how do we solve this particular question? Solution. Now, solution, they said the sum of the first 10 terms of an AP. So the first we are given there is S of 10. The sum of the first 10 terms of an AP is 15. So S10 is 15. It said the sum of the next 10 terms. All right, so the first term gives you 15. The next term means adding an extra 10 to the first one. That becomes 10 plus 10, which is 20. So number 2, you're given S20. Number 2, you're given the sum of the first 20. They give you for the first 10, then the next 10 again. That's 10 plus 10, 20. That value is how many there? 215. 215. You've asked to find the AP, right? All right. So let's see. Let's see how we can solve this. Let's recall something. Recall. Let's recall formula. Recall that when it comes to sum of an AP, sum of n terms of an AP is equal to n over 2 into 2a. Okay, it should be a square bracket. 2a plus n minus 1d. So you have this. All right. For S10, what you have is that n becomes 10. All right. Before this, were we given the first and no? Were we given first and common difference? No, we were not. All right. So fine. That's okay. That becomes n is 10. So 10 over 2 into 2a, the value of a we don't have, plus S10. So n is 10. I'll place n here by 10. That becomes 10 minus 1 into d. I have this. Now proceeding with this, what do we have here? We have the S10, sum of the first 10 terms. 10 over 2 gives you 5. 5 into, this would be 2 times a, 2a plus 10 minus 1 is 9, and then you have d. So 9d, you have this. So this is S10. Expanding this again, S10 is equal to 5 times 2a gives you 10a plus 5 times 9 is 45. So 45d. So you have this. In essence, we equate this to this. Let's call this equation 1. Let's call this equation 2. So we say equating to 1, equating to equation 1, we have the S10, which is this. You can say 10a plus this one here, 45d is equal to, what's S10 here? S10 here is 15. So it's equal to 15. Let's call this equation asterisk. All right. So we've gotten this. This is for S10. Let's do for 20. Also, let's do for 20. For 20, we have that S20 will be equal to, for S20, n is now 20. It becomes, n is now 20. It becomes 20 over 2. So I have this as 20 over 2 into 2a, that's 2 times a, plus n minus 1. What's n? N is 20 in this case. So it becomes 20 minus 1, n minus 1 d. So we have this. All right. Let's proceed with this. From here we have S20 is equal to 20 over 2 gives you 10. 10 into, this gives you 2a. So 2a plus, okay, what do we have here? We have this as 20 minus 1, which is 19, and then d. So we have this. Okay. So proceeding here, what do we have? We have this as equal to, let's expand this. If we expand this, this is equal to 20 times 2a, 10 times 2a gives you 20a plus 10 times 19d gives you 190d. So we have this. At this point, we can now equate this to equation 2. So equating to equation 2, what do we have there? We have this one here, S20, which is this. We have 20a plus 190d is equal to, S20 there is 215. All right. We'll call this equation asterisk. So we have this. All right. So let's proceed with this question. Now, at this point, there is something very critical to note for this question at this point. Now, here's the thing. If you try to understand the question, they said the sum of the first 10 terms was 15. All right. So from term 1 to term 10, when you sum them up, you have your answers what there? 15. That's the sum. Also, they said the sum of the next 10 terms. That means if I sum from 11 to 20, which is the next 10 terms, your answer there is what there? 215. All right. But if I'm to get the sum of the first 20 terms, the sum of the first 20 terms will be the sum of the term from 1 to 10, which are the first 10 terms, plus the sum of 11 to 20, which are the next 10 terms. In essence, I'm saying that S20 is supposed to not just be 215, but 215 plus 15. Because the sum of the first 20 terms here, this one here, is supposed to be the first 10 terms, 15, plus the next 10 terms, which is 215. Please take note of this one here, okay? Yeah, so that's it. So if you look at 20, 20 is 1 to 10. All right, let me write this bigger. 1 to 10 will sum, and then 11 to 20 will sum. When you sum 1 to 10, the first 10 terms, the value there is 15, which is this. But when you sum 11 to 20, the value, which is the next 10 terms, this is the first 10 terms, this is the next 10 terms, 11 to 20, that will give you 215. Now, if I'm to get the sum of the first 20 terms, sum of first 20 terms will be from 1 up to 20, this. That means I'm combining from here plus this. So it becomes 15 plus 20. And 15 plus 20 gives you what? 15 plus 215, please. All right, that becomes 15 plus 215. And 15 plus 215 gives you 230. So S of 20 is 230. So I would come here and make this 230 instead. All right, 230 instead. Yeah. So this is better. Now, if this is true, we can see that we can break this down. All of them are divisible by 2. So I can say divide by 2 instead. Divide by 2. Let me break this one down. So I'll divide by 2. 20a divided by 2. Let me just go straight. All right. 20 divided by 2 gives you 10a plus 190 divided by 2 gives you 95. D is equal to 230 divided by 2 gives you 115. At this point, we can now call this asterisks. All right, so we have 10a plus 95d is equal to 115. All right, so we now have two different equations in terms of a and d, in terms of a and d. So we can solve them simultaneously. Since we have 10a here and 10a here, we can just subtract them. So I will say subtract equation 1, no, not 1, asterisks, please. Equation asterisks, this one, from equation hash. Let's subtract them. What do we have? What do you have there? Asterisk is 10a. That's as 10a plus 95d. This is equal to 115. So 115 minus. Next we have 10a. So 10a plus this one here, 45d. 45d is equal to 15. So you have 15 here. All right. So let's subtract them. Of course, 10a minus 10a, it goes off, cancels out. 95 minus 45, that gives you 50. 50d is equal to 115 minus 15. That gives you 100. So divide here by 50. divide here by 50. This cancels this, and you have that d is equal to 2. So you have the value of d there as 2. All right, so having got the value of d, I would just substitute this. So put d into equation asterisk. This one here, so I can get a. All right, so this is the value of asterisk already. It's already here. So I'll just proceed. All right, imputing values here. This is 10a, 10a plus 45 into d. What is d? D is 2. So into 2 is equal to what there? 15. So I have this. All right, let's solve this. This becomes 10a plus 45 times 2 is 90 is equal to 15. So we have 10a is equal to 15. All right, bring 90 over here, becomes minus 90. So I have 10a. 10a is equal to, you have 15 minus 90, that's about 75. 75, okay? Divide here by, let's start with, should we use 10? Okay, divided by 10, divide here by 10. This cancels this. So a, first term a, is equal to 75 all over 10. 5 can divide both of them. 5 here, this will give you 15. 15. 10 divided by 5 gives you 2. All right, so this is equal to 15 over 2. So the first term is 15 over 2. The common difference is 2. All right, okay. We have to find what exactly. Let me check again. In the question, we have to find what exactly. Let's see. In the question, we are asked to find so this gives you 10a is equal to 15 minus 90 gives you minus 75. To get a, divide here by 10. Divide here by 10. This cancels this. A is equal to minus 75 over 10. 75 divided by 5 gives you what there? 15. Yep. 15. 10 divided by 5 gives you what there? 2. So A is equal to minus 15 all over 2. So you have this. The question says we should find the AP. How do we find the AP? To find the AP, we need first term, second term, and let's see perhaps third term. Right? So let's see what that will give us. Let's get first term. So first term A is equal to what there? Minus 15 all over 2. Second term, A plus D. A plus D becomes minus 15 over 2. A plus D, we got D as what again there? 2 plus 2. So if you solve this, this would give you, I'll just go straight to the final answer. This will give you minus 11. Minus 11 all over 2. We have this. Yeah? Okay? The third term will give you A plus 2D. A is minus 15 over 2 plus 2 times D. What is D? D is 2, right? Yep, 2. So this would be equal to minus 15 over 2 plus 4. All right. So this will now be equal to, just go through to solving this. Take your LCM and solve this. This will give you about, minus 7. Yeah? You have your answer as minus 7 over 2. So therefore, the AP, the arithmetic progression, is, the first thing there was A minus 15 over 2, comma, the second term is minus 11 over 2. The third term, A plus 2D, is minus 7 all over 2. Then you put dot, dot, dot. Dot, dot, dot means it continues, all right? So basically, this is how we solve this particular question. So as usual, I'll give you a task for you to solve. Now your task is this. I have given you 1, 2, 3, the first 3 terms. I want you to provide the fourth term and the fifth term. So what will the fourth term and the fifth term in this particular AP? What will it be? That's your task. All right. So find the fourth term and the fifth term. Leave your answer in the comment section. All right. Let's look at this question on the sum of an AP. The question says, find n given that n is greater than 0 if the sums of the following arithmetic progression are equal. So you have you're given 2 different arithmetic progression. All right, solution. Let's copy out the AP. The first thing we have there is 1. The first AP we have there 1, 5, 9, 13, and it continues until the nth term. This is your first AP. You're given a second AP there, 19, 17, 15, 13, and that continues again until your nth term. You're given these two here, and your task here is to find the value of n, and they said n should be greater than 0 if the sum of the following AP are equal. All right. The sum of this AP and this AP are equal. We'll call this the first AP. All right. So say for the first AP, for the first AP, you have 1, 5, 9, 13. For your first AP, let's get the first term. All right. The first term A is equal to what you have here, which is 1. Right, the first term is 1. To get D, the common difference, all you have to do is to subtract the second term, subtract the first term from the second term. That becomes second term 5 minus first term 1. 5 minus 1 gives you 4. So it's that simple, all right? To get the first term, it's just the A. To get a common difference, subtract the first term from the second term. 5 minus 1 gives you 4. So you have this. Let's get the sum of the terms here. So sum Sn is equal to, the formula for sum of an AP is n all over 2 into 2a plus n minus 1, n minus 1, then you have d. So you have this. All right, so I have this. Proceeding with this, let's impute values. So for this, sum of the n term, so have Sn is equal to n over 2, yeah, into 2a, that's 2 into a here is 1, 2 into 1, plus n minus 1. What's d? In this case, d is 4, so into 4, we have this. Let's further simplify this. We have Sn is equal to n over 2 into 2 times 1 is 2, plus we can expand this. 4 times n is 4n minus 4 times 1 is 4. Right? 4 times n, 4n. 4 times 1 is 4. Bring down the minus. From here, we have that Sn is equal to n over 2 into, we'll take this one first, 4n then 2 minus 4 is minus 2. I am done simplifying the first AP. All right, so that's for the first AP. Let's take for second AP. For the second AP, what we have there is 19. So 19, 17, this one here, 15, 13, and it continues. Let's get the first term and the common difference. The first term here, A, obviously, A here is equal to what I have here, 19. So the first term for the second AP is 19. To get common difference, D, we said subtract first term from second term. So simply second term minus first term. That becomes 17. Second term minus first term 19, and that's equal to minus 2. So I have this. All right, if this is true, let's get the sum. What's the sum there? The sum for second term, Sn, is equal to same formula, n over 2. That's n over 2 into 2a. That's 2 times a. What is a? A is 19. 2a, 2 times 19, plus n minus 1 into d. What's d there? D is minus 2. All right, and multiply with minus 2. So you have this. So expand this. What do you have there? In expanding this, I have that Sn is equal to n over 2 into 2 times 19 is 38. Yeah? Yeah? So this is, let's expand this. So in expanding this, what we'll do is simply plus, okay, so guess how to do this. Plus times minus is minus 2 times n is minus 2n. So I have minus 2n, and then you have plus times minus is minus 2 times minus 1 is plus 2. So you have this. All right, so in expanding this, you have this. You could take them one by one. All right, minus 2 times n minus 2n minus 2 times minus 1 plus 2 plus to them will give you the same thing. So you have this basically. So combining this is equal to n over 2 into, we took the n first. Now, usually here, I would have done 2 minus 4 to give you minus 2 plus n. But I had to take the n term, that's positive term, before negative term. So that's why I had plus 4n minus 2. Here, if I use the same concept, we can see that the negative term is now the one having n. So you could choose to now say probably minus n first, minus 2n, just so that you can have the minus n first. Or you could still work with the principle of saying positive term before negative term. The positive term will be 38 plus 2, which is 40. That's a positive 40. The negative term is now minus 2n. All right, so the principle I'm working with is simply positive term before negative term. It's just a rearrangement. If you choose to take negative before positive too, that would still work, no problems. All right, so we have this. So the sum of the terms for the first AP is this. The sum of the terms for the second AP is this. We're asked what value of n will they be equal? If they are equal, if Sn, let me call this, okay, let me call this the sum for the first AP. Let me call this Sn1, all right? Sn1 means sum of the first AP. Yep. So I'll call this Sn1 just to demarcate them. All right. Then I'll call Sn2 the sum for the second AP. All right. So if the sum of the AP for the first AP is equal to the sum of the AP for the second AP, this. So what would we have? We'll have that this value here is n over 2 into 4n minus 2. This is equal to this for the first one. For the second one, you have n over 2 into 40 minus 2n. So you have this. Now, whenever you're doing mathematics and you have the same term on both sides of the equation and they are multiplying, they can cancel out. What do I mean? This is n over 2. This is n over 2. This is multiplying this. This is multiplying this. The same term on the same position on both sides of an equation, they can cancel out. So this will cancel this. I'm left with 4n minus 2 is equal to 40 minus 2n. So I have this. Let's solve this. In solving this, I have, let's take the n first. I'll take this n from here this way. Becomes 4n plus 2n. So I have 4n plus 2n is equal to, so minus 2n comes over here, becomes plus 2n. 40 minus 2 comes over here, becomes plus 2. It's equal to 40 plus 2. 4n plus 2n gives you 6n is equal to 40 plus 2 gives you 42. So I have this. All right. Now let's divide this. To get n, divide here by 6. Divide here by 6. This cancels this. N is equal to 42 over 6 gives you 7. Right. So the correct answer there is 7. Right. So we need to take the sum of the first 7 terms of the first AP, and then we'll take the sum of the first 7 terms of the second AP. Both of them will now have the same value, right? Yeah, they will both have the same value, right? So it's the 7th term. The sum of the first 7 terms of the first AP will give you the same value as the sum of the first 7 terms of the second AP. That's a simple interpretation, all right? All right, guys, so that is the solution to this particular question. Let me give you a task. Okay, let's do it this way. So for your task, what to do is simple. We've just agreed that if I take the sum of the first 7 terms of the first AP, I will get the same value as if I take the sum of the first 7 terms of the second AP, right? That's what we've just agreed. Your task now is to get that value. So your task now is to get what is the value of the sum of the first 7 terms of either the first AP or the second AP. Use any of them, solve that question. What's the task? What is the sum of the first 7 terms of either one, whether the first AP or second AP? Find the sum of the first 7 terms. Leave your answer in the comment section and I'll give you a reply. I will tell you if you're correct or not. All right. Let's look at this question on arithmetic progression AP. The question here says, the first 3 terms of an AP are x, 2x plus 1, and 5x minus 1. Find x and the sum of the first 10 terms, right? Find x and the sum of the first 10 terms. All right, so let's solve that question. Now, solution. They gave us an AP. They said we have what there? The first term of the AP there is x. And then you have 2x plus 1. And then you have 5x minus 1. You have this. So these terms are in arithmetic progression. You're asked to find the value of x and the sum of the first 10 terms. All right? The value of x and the sum of the first 10 terms. So how do you solve that? Now, for this question, what you want to note is that you want to get the value of x. And how do we get that? Don't forget that we said when it comes to an AP, we said the first term A, let's do this. The first term A is equal to x. The second term is 2x plus 1. The third term is 5x minus 1. For any given AP, right, if I subtract consecutive terms, I will have a common difference. Let me give you an instance. Let's say I have these terms in AP 3, 5, 7, 9. These terms are in AP. Now, notice that if I do 5 minus 3, my value will be 2. If I do 7 minus 5, 7 minus 5, my answer will be 2. If I do 9 minus 7, 9 minus 7, my answer will be 2. Notice that you have a constant term. And that's why we defined an AP as a sequence where consecutive terms differ by a constant number. So I'm saying that if I do this minus this, it will be equal to the value of this minus this. Hence, we can say that 5 minus 3 is equal to this minus this, 7 minus 5. This would work. This is the task, or this is the idea that we use in solving this question. So we can say for an AP, the second term minus the first term, 2x minus 1, second term minus the first term, x. This value here will be equal to the third term, 5x minus 1. This minus the first term, but minus second term, please, which is 2x plus 1. 2x plus 1, 2x plus 1. So please watch this out, okay? So you have second term So for this, note that for an AP, you have second term minus first term, 2x plus 1. This minus first term, x, will be equal to third term minus second term, which is 5x minus 1. This minus second term, 2x plus 1. 2x plus 1. You have this. All right, so we have this. Let's expand this. We'll have this as 2x plus 1 minus x is equal to, this gives you 5x minus 1 minus to 2x gives you minus 2x minus to plus 1 gives you minus 1. We have this. Let's subtract value. 2x minus x gives you x, then plus 1 is equal to, here we have 5x minus 2x, that gives you 3x, minus 1 gives you minus 2. So we have this. All right, what next? Let's collect like terms. I'll move x over here. I'll move minus 2 over here. So I have here plus 1. Move minus 2 over here becomes plus 2 is equal to, this is 3x. 3x. X comes over here becomes minus x. 1 plus 2 gives you 3. So I have 3 is equal to 3x minus x gives you 2x. From here to get x, divide here by 2 and divide here by 2. This cancels this. We'll have x as equal to this over this, 3 over 2. All right. With this, we've gotten our first term. Don't forget that x is our first term. So therefore, our first term a is equal to 3 over 2. Let's get common difference. Common difference d. The common difference, as we said, is simply the, what's it called? Second term minus first term, which gives you second term 2x plus 1, second term minus first term x. The value of x is 3 over 2. Let's impute that value. That will give you 2 into x. X is what there? 3 over 2. So 2 into x, this plus 1 minus x. Minus what's x? X and a are the same thing. So minus 3 over 2. All right, let's expand this. Of course, this will cancel this. So d will be equal to 3 plus 1. So plus 1 there. Minus 3 over 2. Simply take your LCM there. Your LCM there would be 2. All right. So 2 divided by 1 will give you 2 times 3 gives you 6. So I'll have 6 plus, this is all over 1. This is all over 1. That's what I'm doing here. All right. So 2 divided by 1 gives you 2. 2 times 3 is 6. 2 divided by 1 gives you 2 times 1. 2. 2 divided by 2 gives you 1 times 3. So it's 3. The sign is minus. So minus 3. So what do I have here? D is equal to 6 plus 2, 8. 8 minus 3, 5. That becomes 5 over 2. Yep, 5. All right, so we've gotten the value of x, which was the first part of the question. We've done that. The second part of the question said we should do what there? Find the sum of the first 10 terms. So sum of first 10 terms. That will be Sn. So S of 10. Recall that the sum of term of an AP, Sn, is equal to n over 2 into 2a plus, in bracket, n minus 1d. This is a formula for the sum of terms of an AP. So n is now 10 because it said 10 terms. So n over 2 becomes 10 over 2 into 2 times a. 2a. What's a there? A is 3 over 2. That's 2a plus n minus 1. What's n? N is 10. Number of terms, 10 terms. So n minus 1, 10 minus 1. This into d. What is d? D is 5 over 2. 5 over 2. So we have this. All right, expand this is what you have here. This is equal to 10 over 2 is 5. So 5 into, let's see what we have here. 2 will cancel 2, you're left with 3. 3 plus 10 minus 1 is 9. 9 into what I have here, 5 over 2. So we have this. Simplify further. This is equal to 5 into, this will give you 3. This is 3 here, plus 9 times 5 is 45. That becomes 45 all over 2. 9 times 5 is 45 over 2. All right, this is equal to, let's work on this. What I have here is 5. All right, for this, I'll take the LCM. This is all over 1. The LCM here is 2. All right, 2 divided by 1 gives you 2. 2 times 3 is 6. So I have 6 there. Remember, 6 plus 2 divided by 2 is 1. 1 times 45 is 45. So I have plus 45. So I have this. This will be equal to 5 into 6 plus 45. That will give you about 51. So that becomes 51 all over 2. Now expand this. 5 times 51. This will be equal to, that 51 times 5 gives you 255. That's a value all over 2. So that's a value. In essence, the sum of the first 10 terms as required would be equal to 255 all over 2. That's your answer. We could put this in decimal. Yeah? Put this in decimal. What do you have there? That was about 117. Let's see, just so I can be on track, please. 255 over 2. Okay, 125.5. 127, please. 127.5, please. 127.5. That becomes your answer. All right? All right, so the sum of the first 10 terms, 10 consecutive terms would be 255 over 2, which in decimal is 127 over 5. So basically, this is how we solve this question. As usual, I'll leave you with a task. Your task is to find the value. Please take note. Your task is to find the value of the sixth term of this AP. This is an AP. You have your first term, your second term, your third term. What is the numerical value? Don't give me in terms of x. No, give me the actual number. What do I mean? What I mean is that for here, they gave us x as first term. The actual value of x after solving is what there? 3 over 2. Your task is simple. For this same AP here, give me the actual number for the sixth term. 6. The sixth term. Leave the answer in the comment section. I'll give you a reply. I'll tell you if you're correct or not. All right. Let's look at this question on AP. The question here says, the question here says, the first term of an AP is 25 and the third term is 19. Find the number of terms in the progression if each sum is 82. All right? Okay, so solution. Let's solve this question. First things first, what are we given in this question? So given, in the question here, they said the first term, number one, you're given A, first term, as equal to how many? 25. So you have 25 here. B, on number two, they say the third term. And we know that the third term of an AP is A plus 2D. That's the third term. The third term is given as how many there? 19. So you have this as 19. What else? They said find the number of terms in the progression if each sum is 82. Number three, they said the sum of a particular number of terms, Sn, is equal to 82, and you're asked to find the number of terms. So n, number of terms, is equal to unknown. All right, let's solve this question. Now, what do we do? In this question, we're given the first term, 25. We're given the third term, a plus 2d, 19. We have the sum of a particular number of terms, which is 82. So the question is, how many terms of this particular AP do you have to sum or add up to get 82? That is the question. What do you do? First things first, we already have A. That's not a problem. What we have to find next is the value of D. We need to find the value of the common difference, D. And to do that, what we'll simply do is put A as equal to 25 into, let's call this question 1. Okay, call this 1. I'll call this 2. So into equation 2. All right. So for equation 2, I have A plus 2D as equal to what there? 19. Let's put the value of A there. A is 25. So I have 25A plus 2 times D. So I've replaced A with 25 as equal to 19. To get the value of D, I'll move 25 over here. You now have 2D is equal to 19 minus 25. From here, we'll have that 2D is equal to 19 minus 25 is equal to minus 4, right? 19 minus 25, please, is equal to minus 6. All right, 19 minus 35 is equal to minus 6. All right, to get D, divide here by 2, divide here by 2. This will cancel this. So D is equal to minus 6 over 2 will give you minus 3. All right. So we've now gotten our first term as 25. We've gotten our common difference D as minus 3. Now at this juncture, let's now recall, we need to involve the concept of summation or sum of an AP. Let's recall that the sum of an AP, Sn, is equal to n over 2 into 2a plus n minus 1d. You have this. All right? Yeah? And you have that this value is equal to how many there? 82. So we're saying that 2a, or n over 2 first, we're saying that n over 2 into 2a plus n minus 1d. This, yeah, this is equal to, this is Sn, and you've said Sn is 82. Okay. So this is equal to 82. Next I have to do here is to substitute the value of A and D. A and D. So what do you have there? This becomes n over 2 into 2a. That's 2 times a. What's a there? A is 25. 25 plus n minus 1 into d. What is d? D is minus 3. This into minus 3 is equal to 82. Let's now solve for n. From here we'll have n over 2 would give you 2 times 25 is 50, plus times minus 3 times n gives you minus 3n, plus times minus 3, minus 3 times minus 1 gives you plus 3. So we have this. All right, so please watch this. Plus times minus 3 times n gives you minus 3n, plus times minus 3 times minus 1. Minus is plus, 1 times 3 is 3. So I have this. This is equal to 82. Now I'm proceeding with this. This will give you n over 2 into 50 plus 3. So I'm taking the numbers. 50 plus 3 gives you 53. Then you have next as minus 3n. Minus 3n. This is equal to what there? 82. All right, so what do we do next? To cancel out these two here, we can say multiply both sides by how many there? 2. So this can cancel out by 2. If I multiply both sides by 2, what do I get? If you multiply both sides by 2, you get 2 times n over 2 into 53 minus 3n is equal to 2 times how many? 2 times 82. All right, from here, this will cancel this. N into 53 minus 3n, this is equal to 2 times 28. That will give you 164. You have this. All right, so expand this. N times 53 is 53n minus n times 3n should give you 3n squared is equal to 164. Right, move this over here. You have 53n minus 3n squared. This is 164. Comes over here, becomes minus 164 is equal to 0. Arrange this as a quadratic equation from the term where n is highest, or where n has the highest power, minus 3n squared, then this one here, plus 53n, then this one here, minus 164 is equal to what there? 0. So I have this. All right. The next thing to do here, we now have a quadratic equation. So I'll just pick my calculator and solve this quadratically very quickly. Let's do that. You could use any method of your choice in solving quadratic equation, but I'm just going to use calculator there. You could use completing the square method, right? You could use completing the square method. You could use formula method if you want to, but I'll go straight to using calculator. Here, A is minus 3, B is 53, and C is minus 164. If you punch that, you have X, you have the first value of N as being what there? 41 over 3, and also you have N as being what there? 4. Let's just confirm that we are correct. This is minus 3n squared, okay, plus 53 minus 164. So you have either this or n is equal to 4. 82. Now we are taking the whole number there. We're taking the whole number there. So pick this one here, the whole number. So n is equal to 4. That's the whole number. All right. So, and so that means at the fourth term, we should have our sum as being equal to 82. That's it. All right. So we pick the whole number and n will be equal to 4. And just to confirm that we are correct, let's see. The first term there was how many there? The first term was 25. And the common difference was how many there? Common difference was what? Minus 3. So let's get the sum. Let's get the first four terms. The first term would be A. Second term, let's get the sum of the first four terms. Second term would be A plus D. Third term would be A plus 2D. And fourth term would be A plus 3D. All right. So we got 4. And we're trying to verify our answer. First term plus second term plus third term plus fourth term. Let's confirm this. So A is how many there? A is 25. This is 25 plus, this is A, 25 plus D. D is what there? Minus 3. So we have this. Plus, this is the second term. Plus for third term, we have A, 25 plus 2 times D. What is D there? D is minus 3. This is third term plus fourth term. The fourth term is A, which is 25. 25 plus 3D. 3 times D. D is minus 3. So we have this. This is equal to, what we have here is 25 here plus, this is 25 plus minus is minus 3 plus, this is 25 plus, no, plus 2 times minus 3 is minus 6. So 25 minus 6. Okay? Plus, you have 25 plus 25 into plus 3 times minus 3 gives you minus 9. So let's sum this value up. What do you have here? This is 25. 25 plus a second 25 plus, no, minus 3. So minus 3. 25 plus 25 minus 3 plus 25 minus 6 plus 25 minus 9. If you sum that up, your answer will give you 82, which is what we got. Exactly what we got, 82. So that proves that our answer is correct. All right. So this is how we solve this question. And we've just verified that our answer is correct. So whenever you have this kind of case, all right, where you're having a fraction and a whole number, please just choose the whole number. Right. So in essence, if I sum the first 4 terms, I'll have this. Choose the whole number. That's the correct answer. All right. All right, guys. So before I go, as usual, I'll give you a task. Now, your task is very simple. Your task is to get, for this term here, right, we have your first term, second term, third term, fourth term. Now, your task is to get the 20th term, T20. What will the 20th term be for this particular AP? What will the 20th term of this particular AP be? All right, get your answer, right, and leave your answer in the comment section, and I'll give you a reply. I will tell you if you're correct or not. All right. Let's look at this question on the sum of an AP, or rather, the application of the sum of an AP. The question here says, 2 men, A and B, started work at the same time. A at a salary of 400,000 naira and with an annual increment of 5,000 naira, and also B with at a salary of 500,000 naira with an annual increment of 4,000 naira. After how many years will their total salaries end be equal? All right. All right. Let's see how that works. So solution now. Solution. So you're having man A and man B. Now for man A, let's start with for man A. For man A, the salary he earns, A, is equal to 400,000 naira. 400,000 naira. and the annual increment, that's the difference, D, is equal to 5,000 naira. That's the value. For B, for man B, that's for B, his salary A is about 500,000 naira. That's 500,000 naira. And his annual increment, the difference in his annual increment is just 4,000 naira. Right? I think that was what they said here. Let's see. Yeah, that's what they said here. And they're asking, after how long will their will what? Will their total salary be will their total salaries end be equal? That's the question. After how many years will their total salaries end be equal? All right, so let's solve this question. Okay, so how do we solve this question? Now to solve this question, let's get the sum, right, of the salary for A. Right, sum of salary for A, sum of salary for man A. We'll have Sn. We said the sum of an AP. Let me write the formula here. Sum of an AP Sn is equal to n over 2 into 2a into 2a plus n minus 1d. Would have this. All right. So for A, we'll have, let's call it S of A. S of A will be equal to n over 2, or let's call S of n for A, better still, S of n, so that you don't get confused. So S of n for A is equal to the same n over 2 into 2A. For man A is 400,000, so into 2A, 2 into 400,000, all right, plus n minus 1, plus n minus 1 into D. Okay, let's get D for man A. D for man A is 5,000. So this into 5,000. So you have this. All right, can we break this down? This would be equal to n over 2 into, this will give you 2 times 400,000 is 800,000 plus 5,000 times n is 5,000 n minus 5,000 times 1 is 5,000. So we have this. So this is equal to n over 2 into 800,000 minus 500 minus 5,000. That will give you 795,000. This, then plus 5,000 n. You have this. All right. Yep, 800,000 minus 5,000 gives you 795,000, then plus, bring this down. So this is for A. This is the sum of the salary for A. Let's go for B. Yep, let's go for B. So sum of salary for B. For B, what do you have there? We'll have Sn of B is equal to n over 2 into 2 times A, 2 times, for B, for man B, A is 500,000. Okay, so 2 times 500,000, 500, 1, 2, 3, 500,000 plus n minus 1 into D. For B, D is 4,000. So into 4,000. All right, so we have this. Let's expand further. If we expand further, we'll have Sn, the sum of the salary for B as being equal to n over 2 into 2 times 500,000 gives you 1 million. That's 1 million in naira. 1 million naira plus n times 4,000 gives you 4,000 n minus 1 times 4,000 is 4,000. So we have this. All right. So this would be n, the sum of the salary for B would be n over 2 into 1 million minus 4,000 gives you 996,000. Yeah? Yes, plus 4,000 n. So we have this. All right. So we have this. All right, guys. So what next? What next? What next? So at this juncture, next thing we do, they said for them to be equal, for their salaries, for their salaries to be equal, what will happen is that the sum of the salary for A, the sum of the salary for A will be equal to the sum or total, total salary for man B. That's it. So let's equate them. Let me get a chalk. Let's equate them. So I also have my calculator here. For A, this value is this, right? We have n over 2 into 795,000 plus 5,000 n. This is equal to, for B, we have this n over 2 into this one here, 996,000 plus 4,000 n. So we have this. All right. Again, we have this and this. Whenever you have the same thing, n over 2, on the same, on opposite side of an equation at the same position, right? That means this one here is multiplying this, and this one here is multiplying this. So basically, they are the same thing. This can cancel this, right? The same term at the same position on both sides of an equation, they can cancel out. With this, now I am left with 795,000, this plus 5,000 n is equal to 996,000 plus 4,000 n. At this juncture, we'll say collect like terms. So collect like terms. Let's collect like terms. What do we have? Take this one off. If we take like terms, what are we having there? I'll move the terms having n here. It becomes 5,000 n. So 5,000 n. You have 4,000 on the other part here. Move the 4,000 over here, becomes negative. So minus 4,000 n is equal to, here you have 996,000. So it becomes 996,000. 996,123 minus, this man is positive. Move it over here, becomes negative. So minus 795,123. All right, so we have this. 5,000 minus 4,000 gives you 1,000. So 1,000 n is equal to, let's subtract these numbers. What do we have there? We have 996,000 minus 795,000. That's about Yeah, that's about 201,000. That's what you have there. 996,000 minus 795,000. Okay, to get n, divide here by 1,000, divide here by 1,000. So this would cancel this. We have that n is equal to 1, 2, 3 cancels 1, 2, 3. You're left with 201. So therefore, put it in a statement. You say therefore, their salary will be equal after 201 years. Therefore, the salary of A and B will be equal after what's there 201 years. So that's your answer. All right. Though that's very crazy to even think that somebody has to work for 201 years to have equal salaries. It's crazy, but then that's your answer. Okay. So this becomes the solution to this question, right? So that's how you solve this question. All right. So if you enjoyed this video, don't forget to, as usual, hit the like button, like this video. Oh, before I forget, let me give you a task. Let me give you a task for you to solve. So just hang on a bit. Let me try this question for yourself. The question here says, two men, A and B, started job at the same time. A at an annual salary of 4,000 naira with an annual increment of 1,000 naira, and B at an annual salary of 5,000 naira with an annual increment of 500 naira. In which year of their services will their monthly gross pay be the same? In what year of their service will their monthly gross pay be the same? Also, after how many years will they earn the same amount? All right. So that's the question. Now you try to answer this question. Pause this video, answer this question, leave your answer in the comment section. All right. All right, guys. So if you enjoyed this video as usual, don't forget to hit the like button, give this video a thumbs up. Don't forget to also leave a comment. I gave you a task. Solve that task. All right. Pause this video right now. Solve that question. Leave your answer in the comment section, and I'll give you a reply. I will tell you if you're correct or not. Don't forget to also subscribe. If it's your first time and you're yet to subscribe, please do well to join our community. Subscribe, hit the bell icon, and select all so that you get notified whenever we upload new content. Then finally, do well to share this video to your friends and your colleagues so that they can also learn. Thank you, and see you in our next class.